Hello, welcome to my class on this dural reflection or dural folds. This dural folds, they are actually part of a meninges, and I think, as you know, this meninges consist of uh, cranial meninges and spinal meninges. This cranial meninges cover the region of the brain, and spinal meninges covers the region of the spinal cord, and both consist of this dura, arachnoid, and biometer. Now look at this image. Here it is a schematic diagram showing the region of skull and cranium. Now within the different layers of the scalp, that is within skin and this aponeurosis, there is a cranial bones, and within the cranial bones there are three meningeal layer in between this brain tissue and this cranial bones. This dura mater, again, it is divided into two parts in the region of this cranial meninges, while in the region of spinal meninges, it remains a single layer. So what are the two divisions of the dura mater? Here you can see it is single layer, but in this region you can see it splits into two layers. One is closely adherent to the bone. This layer is known as endosteal layer, and another layer below this one, it is the meningeal layer. This meningeal layer is closely attached to the this arachnoid matter, while this endosteal layer is adherent to the this cranial bones. Now, usually these two layers, that is endosteal and meningeal layer, they are not separated. They are uh, closely adherent to each other, but in some of the places, like here, they are separated. And this meningeal layer, it dips down into some of the depressions in the region of brain tissue, this within this sulci, and it forms a fold. So these are the dural folds or dural reflections. Now look at this red color area bounded here. These are venous sinuses. So these venous sinuses, they are enclosed by this endosteal layer and the meningeal layer. And CSF is draining into this region from the this arachnoid, subarachnoid space via this arachnoid granulations. Now, the knowledge of the dural fold is important because the dural septa divides the cranial cavity into compartments, and this compartment separates different part of the brain, thus they restrict their movements. Also, this dural fold, as you can see here, they encloses this venous sinuses. Again, these venous sinuses are very important clinically. Here it is one of the image showing the region of the dural venous sinuses, how they are formed by these two layers or of the dura mater, and here it is arachnoid granulation. Uh, through which this CSF is running into this venous sinuses, and this one is the fold or the dural fold in between these two half of the brain tissue. Here you can see the two layers of the dura mater. One is endosteal layer that is closely adherent to bone in this prosected image. Look at the bones. Here this is the dura mater. One layer is closely attached to the bones. Another is attached to the this arachnoid mater. And in some situation here it is the sagittal sinus, and into the larger sulci or depressed region, this meningeal layer forms the dural fold, and it encloses the venous sinuses. Now, there are four major dural folds. That is, one is falx cerebri, separating two cerebral hemispheres. Tentorium cerebelli, separating this occipital lobe of cerebrum to the cerebellum. Falx cerebelli, separating two half of the cerebellum and diaphragma sella. It is above the pituitary fossa or sella turcica. Now I'll tell you about the details about their attachments and what are the venous sinuses enclosed by each fold. First come to the falx cerebri. This falx cerebri separates two cerebral hemisphere and it is located in mid-sagittal plane. And look at the shape of the falx cerebri. It is sickle shaped, having anterior pointed end and posterior broad end, having upper convex margin which is attached to the inner surface of the cranium just below the sagittal suture, and inferior concave free margin. Now look at the attachment of anterior end and the posterior end. Anterior end is attached to the one bony elevation that is known as crista galli. It is one of the part of ethmoid bone, and posteriorly it is attached to the occipital bone, a part of occipital bone, that is internal occipital crest. Now this posterior broad end, it is attached to the superior surface of this tentorium cerebelli. Now this upper convex border, it is attached to the bones. Here it is enclosing one venous sinus, that is superior sagittal sinus. Now along the inferior margin, it is enclosing inferior sagittal sinus. Now posteriorly, where there is attachment with the tentorium cerebelli, here it is enclosing straight sinus. So in this way, this falx cerebri encloses three venous sinus. One is superior sagittal sinus along the upper convex margin, and inferior sagittal sinus along the inner concave margin, and straight sinus along the posterior end in between the tentorium cerebelli and the falx cerebri. Now look at the tentorium cerebelli. It is a tent separate fold of dura mater, separating the cranial cavity into supratentorial and infratentorial compartment. And the supratentorial compartment, it is divided into right and left half by this falx cerebri. Now look at its shape. It is, as I have told you, tent shaped because this in the central position here there is attachment of the falx cerebri, so it is slightly elevated in this central region, so it appears as a tent shaped. Now this tentorium cerebri, it is having attached margin and the free margin. Now this free margin anteriorly, it forms a U-shaped region that is known as tentorial notch, through which this region of the midbrain is passing. So this is the free end, that is tentorial notch, and attached part is attached to the inner surface of the cranium. So posteriorly, here it is attached to the transverse groove along the occipital bone, and somewhat anterolaterally, here it is attached to the this part of temporal bone, upper margin of petrous part of temporal bone. Here, through this image, you can more easily understand their attachments. So posteriorly, this portion, here it is attached to the transverse groove along the inner surface of occipital. Now look at this anterolateral surface. Here it is attached to the petrous part of temporal bone. Now look at the anterior most region of this attached margin. It is reaching up to the posterior clinoid process, right behind this fossa, that is latercica. And here there is a continuation of this free margin, that is the margins of this tentorial notch. It is extending up to the anterior clinoid process. Now look at the attached margin. In the region of attached margin, it is enclosing some venous sinuses, important venous sinuses. So along the region of this transverse groove on the occipital bone, it is enclosing a pair of transverse sinus. Now along this attached margin on the petrous part of temporal bone, upper margin of the petrous part of temporal bone, it is enclosing superior petrosal sinus. Now in the center, this is the line of attachment of the falx cerebri, where there is a sinus, that is straight sinus, enclosed on the upper surface of tentorium cerebelli. So in this way, this tentorium cerebelli is enclosing a pair of transverse sinus, a pair of superior petrosal sinus, and a single straight sinus. Through this image, again, you can see the superior petrosal sinus, transverse sinus, and straight sinus. This is actually the continuation of this great cerebral vein of Galen. Now, here it is one of the coronal section of the region of the cranial cavity. Look at this image, how this falx cerebri and tentorium cerebelli, they are dividing the cranial cavity into three major compartments. So this tentorium cerebelli, it separates this cranial cavity into supra and infratentorial compartment, and the supratentorial compartment is again divided into right and left half, and these are the venous sinus enclosed within the these two folds. Look at the superior sagittal sinus enclosed along the upper convex margin, and inferior sagittal sinus along the lower concave free margin. Here it is the transverse sinus. Now come to falx cerebelli. This falx cerebelli separates two cerebellar hemisphere, and here along the upper part it is attached to the tentorium cerebelli. Anteriorly it is free, and below here it is pointed and attached to the in the region of posterior margin of this foramen magnum, and posteriorly it is attached to the groove on the occipital bone, and along this posterior margin it is enclosing this occipital sinus. So occipital sinus is enclosed along the posterior margin of falx cerebelli. Now look at this prosected specimen, image of the prosected specimen. Here it is the dura mater. Here it is the cut end of the superior sagittal sinus. Here it is the falx cerebri along this longitudinal fissure dividing these two cerebral hemisphere. Here it is along the lower margin of falx cerebri. There is a straight sinus, and here just below the occipital lobe there is a tentorium cerebelli, along which you will find this transverse fissure, and here it is the falx cerebelli dividing the two half of the cerebellum. Now the last fold is this diaphragma celli, which is actually located above this hypophyseal fossa, that is actually forming the roof of this fossa. Now here in the center it is pierced by pituitary stalk or infundibulum. Now this optic nerve passes over anterior portion of this diaphragm macula here in the region of optic canal, and it is bounded by attachments of the tentorium cerebelli. As you can see, this free margin of the tentorium cerebelli is extending lateral to the diaphragm macula. So this diaphragm macula, here you can see it is circular fold, and in the center here it is stalk of pituitary gland. Now here you can see the list of various dural venous sinuses and how they are draining into finally into the internal jugular vein. This through the superior and inferior sagittal sinus, the venous blood is reaching up to the confluences of sinus. Here it is the junction via this straight sinus. Now through transverse sinus, it is reaching into the sigmoid sinus, and sigmoid sinus is ultimately continuous with the internal jugular vein. Now straight sinus, it is continuation of the great cerebral vein, and the superior and inferior petrosal sinus. The superior petrosal sinus is draining into the transverse sinus, while this inferior petrosal sinus is draining into the internal jugular vein. Now come to this hamartomas. So hamartomas is nothing, it is collection of blood in certain regions of the brain. So mainly there are two type of hamartomas. One is extradural, another is subdural. Extradural is mainly arterial collection of blood between the skull and periosteal layer of dura. The causative vessels is usually this middle meningeal artery, and tearing mainly as a consequence of the brain trauma. Now subdural hamartoma is mainly due to collection of the venous blood in between the dura mater and arachnoid mater, and it mainly results due to damage to the cerebral vein as they empty into the dural venous sinuses. These are the two type of hamartomas. Well, after studying this topic, you must remember different folds of the dural mater and their attachments, and the different dural venous sinuses enclosed by them and their clinical significance. Thank you so much.